Welcome to our YouTube channel. Today we are going to discuss about the topic circular linked list. Circular singly linked list. So, in the case of circular singly linked list, this is the last node. The last node is connected to the header. Means the link part of the last node had saved the address of header. Okay. So in this figure, we had mentioned one, two, three, four, five, six nodes. Okay, six nodes and one header node. So the header node address had saved the link part of the last node. That is the circular link list. In our previous discussion, we had noticed that in a single link list, the link field of the last node is null. Okay, but a number of advantage can be gained if you utilize this link field to store a pointer of the header node. A linked list where the last node points to the header node is called circular linked list. A linked list where the last node pointing to the header node is called circular linked list. That is the pictorial representation of circular linked list. Circular linked lists have the certain advantages over ordinary linked lists. Okay, so in circular linked list, we had connected the last node to that header. I will show one algorithm. That algorithm will search an element in that circular linked list. The algorithm name is search CL. The input is key, the item of search. We are going to search the key in from that circular linked list. The output is the location, the pointer to the node where key belongs, or error message. If the key is found, then it will print as key is found. Okay, or it will print the key is not found. The circular linked list whose addressed to the starting node is known from the header. Then I'm going to explain the algorithm. First, this is the circular linked list header, first node, second node, and this is the last node. Then first PTR equal to header link, which means PTR will save the header link. Means the header link is that address of the first node. Okay, that node have the address 1000. This second node have the address 1002. Third node have the address 1004. Fourth node have the address 1006. Fifth node have the address 1008. Last node have the address 1010. Okay, this is the header node containing the address 2000. Okay, so our first step is PTR equal to header link, which means save the first node address into that variable PTR. So the PTR will point this PTR. First step is PTR equal to header index link. H means header. Okay. So what is a header link? The header link part contains the address 1000. Here the value is 1000. So PTR equal to 1000. So PTR will point first node. That is the PTR. Okay. Then next we had created one loop for traversal. That is a condition while PTR of PTR data not equal to key and PTR not equal to header, then do PTR equal to PTR link. Okay, that is the code for traversing. You have to stop when PTR reach header, which means in direction we had moved from the first node to last node. In circular linked list, we had connected the last node to header. Okay, that is one movement. When we reach the header, should stop the traversal operation. That's why we had uh, used this condition ptr not equal to header. Then ptr equal to ptr link. Okay, first condition while ptr data not equal to key and ptr not equal to header, then do ptr equal to ptr link. Okay, the first the data is matching with the key, then it will print if ptr data equal to key and then return the ptr. The key is found. Okay, if the ptr of data not equal to key, then what will print? Entire list is searched, key is not found. The condition to stop that traversal is ptr data not equal to key and ptr not equal to header. Okay. So traversal in a circular singly linked list involves visiting each node in the list starting from that head and going in a loop until we reach the starting node. That is the condition ptr not equal to header. Since a circular linked list connects the last node to first nodes, so we need to take care of to stop the traversal once we return to that head. That is the condition. So here is how the traversal works in singular English. The steps for circularity, circular singular traversal. First the step is start at the head, beginning in the traversal from the head node of the list. So we are starting from the head node. The head node containing the address of the first node. And second step is visit the node. Move from one node to next node using the next pointer. That is the code for the traversal. And check for circularity. Means once you reach the last node, once you reach the last node, uh, then you will stop the traversal. If you have already visited the head, okay, that is a condition. PTR not equal to head. Okay, if PTR equal to head, then you have to stop the traversal. Okay, means we had traveled visited that all the nodes one time. So I will show that one simple code for circular English. Print the data in that circular English. This is the code that will print the entire circular list. Here I had used one array. AR is the array name. On that array, I had saved 10, 20, 30, 40, 50 values. Okay, so I am passing this data as AR of 0 into first node and AR of 1 into second node, AR of uh, 2 into third node, AR of 3 into fourth node, and AR of 5 into 0, 1, 2, 3, error of 4 into fifth nodes. Okay, and then struct node star head equal to create circular list. I had called that function create circular list single list, and I had passed that array, and n is the size. N is the number of elements. Okay, how you have to calculate this number of elements size of ARR by size of AR of 0. Okay, then I'm going to that function definition of that create circular list. Okay, on that, if value of n equal to 0, then return none. Okay, and then if struct node star head equal to create node AR of 0. Okay, so using that create node function, we will create one node. Okay, so what is the definition for create node function? Struct node star new node equal to struct node star malloc size of struct node. Using dynamic memory allocation malloc function, we had created one node, and the node have the structure data, and the next pointer is used to point the next pointer. Okay, the structure of that node containing the data part and next part. So that is a function for create the node. We have called that function and then passed that ARR of 0 to the newly created first node. Okay, so the data 10 will save into that first node. And then struct node star temp equal to head. Okay, means the temp will point that first node. Then using for loop for int I is equal to 1, I less than n, I plus plus, struct node star new node equal to create node AR of I, and then temp next equal to new node and temp equal to new node. Using that we will create n number of nodes and adding that elements in the array into that node. So we using this for loop we will create 1, 2, 3, 4, 5 nodes, 1, 2, 3, 4, 5 nodes, and saving that AR of 0, AR of 1, AR of 2, AR of 3, AR of 5 into that single circular linked list. That is a code. Okay, and then make the list circularity by connecting the last node to the header. That is the part for the circular single linked list. Stem next equal to head, and then return head. Okay, this head will print uh, to illustrate it is a circular linked list. Okay, so the traverse circular list of head is used to traverse the circular linked list and print the for printing the circular linked list. Okay, now so traverse circular single list struct node star head, and then if head equal to null, then return. Then if the struct node star temp equal to head, stack node star temp equal to head, which means the temp will point the first node and then do print a temp data, and then temp equal to temp next. We had updated the link for the traversal while temp not equal to head. Okay, that is the condition. When the temp reach to that head value, then you have to stop the traverse. Okay, and then at the end of the session, you have to print the head. That is the program for the circular linked list. So the key points in that code is that we are discussing the traverse circular list function start at the head and use do while loop to ensure we visit each node. We stop once we encounter the head again. Okay, that we are discussing here. When we reach the head, then you have to stop. Temp not equal to head. Why? The create circular list function ensures that last node next pointer points back to heads, thus formulating a circular linked list. Okay, how traversal work? The start from the head node, the node data is 10. Okay, the first node data is 10, and visit the node and move to that second node. The second node data is 20, and continues visiting the node in order 30, 40, 50. 30, 40, 50, and after visiting the last node, the next pointer back to the head. This is the data 50. This net that is 50, and so 50, and this will point to header. This will save to this will save the value of header. Now run this. Okay, that is circular linked list. We have maintained the circularity. After visiting the node last node 50, the next pointer back to the head, and we will check if we have come back to the head to end the store. The process ensures that all the nodes are visited exactly once and the traversal stop when we complete the circle. Okay, when we complete the circle, the traversal stop. Stop. Okay. So in this video, we had explained how to create a circular linked list and how to traverse the circular linked list and how to print the circular linked list. We have to write the notes and to your code in your compiler and to write your observations. Okay, thank you. Thanks for watching. If you had any doubt, please comment and share to your friends. If you are not subscribed our YouTube channel, please subscribe and click the bell button for the notification. Thank you. Thanks for watching.